Everyone, welcome to our first briefing of Sunday. Thanks for being here with us. Our briefing this morning is titled Homes Harbor Airborne Chemicals. We have three terrific speakers with us today. They are Marina Vance, Assistant Professor of Mechanical Engineering at the University of Colorado Boulder, Joost de Gouw, Visiting Professor at the Cooperative Institute for Research in Environmental Sciences, the Department of Chemistry at the University of Colorado Boulder, and Heather Stapleton, Associate Professor of Environmental Health at Duke University. We'll get started.
Sorry. It's okay. Good morning, everyone. Thank you for the introductions, Megan. My name is Marina Vance. This afternoon, I'll be talking to you about a study called HOMEChem. HOMEChem stands for House Observations of Microbial and Environmental Chemistry. In my opinion, it's a very unique and interesting study I'm very excited to talk to you about today. The impetus for this study came from the fact that we know that we spend about 90% of our time indoors, and we have a detailed understanding of the chemistry of the outer atmosphere and reactions and processes that take place there. There has been a lot of research and funding being put into that realm over the past few decades. But the same level of knowledge really does not exist for the indoor environment. Although there have been a lot of research studies focused on indoor air quality in general, particularly looking at a few compounds of interest related to human health, only a few studies really have tried to dive deep into the actual chemical reactions and the fundamental chemistry that takes place in the indoor environment. So more studies were definitely needed in that direction. We believe that the chemical processes that take place in the air indoors can be fundamentally different from what takes place outdoors. Even though there isn't a whole lot of knowledge there, we have some hypotheses, and they're based on the fact that, well, we have a lot more surfaces indoors, so reactions with surfaces are probably more important. The types of sources of air pollution can be very, very different from what's known outside and well studied. And the type of oxidants or drivers for chemical reactions can be very different indoors versus outside, where you have a lot of sunlight driving chemistry. So for those reasons, we approached the Alfred P. Sloan Foundation, myself and my colleague Delphine Farmer from Colorado State University, trying to lead a large collaborative field campaign investigating fundamental chemistry, fundamental chemical reactions and processes that take place in indoor environments. And that's what HOMEChem is about. So our indoor environment of choice is a house. We led this collaborative, very large field campaign this past summer in the entire month of June, a little bit of May, a little bit of July of 2018. The project included about 20 faculty members from 13 different universities in the US and Canada. Many of them came from the field of chemistry, particularly outdoor atmospheric chemists that had never done research indoors. Some of them had done some research indoors. And then we also collaborated with a lot of engineers like myself who have a better understanding of the indoor environment and the building itself. This afternoon, I will talk about some results from a few research groups, namely myself and Dr. Farmer's group. I'll present on indoor-outdoor relationship of some air pollutants of choice. I'll focus on black and brown carbon. So what we can tell from there is that activities can be a main driver of the balance of air pollutant indoor versus outdoors. So if you think about, where would you rather be at a given time? If there are no activities going on inside the house, the concentrations of these pollutants are much lower indoors. But then once we start performing some activities like cooking, that picture starts flipping, right? Concentrations indoors can be orders of magnitude higher than outdoors, whatever is going on outdoors at the same time. I'll also be presenting on an experiment that we call Thanksgiving. So we try to mimic or simulate this important cooking-intensive North American holiday. We figured it would be a very interesting experiment, not only for personal interest, but from the interesting chemistry that might be taking place with the interplay of cooking, perhaps some cleaning, the effect of the occupants themselves as guests arrive for your Thanksgiving meal dinner. I'll show some brief results on the Thanksgiving experiment, especially in relation to particulate matter throughout the day. we observed extremely high levels of particulate matter. And if the house were to be looked or viewed as a little city in the US, and we were able to apply the air quality index, which you can find in airnow.gov, and it applies for ambient air quality, right? There's no air quality index for indoor environments. But if we were to apply the air quality index, what we found is that the air quality would be very unhealthy for about 5 to 7% of the time during this particular experiment. So for a little bit of the time, you end up with an air quality index of over 200, and that's only considering particulate matter. So hopefully I'll convey the message that it's important to continue investigations in the indoor environment. There are fundamental chemical reactions that take place indoor that might be important, that are still largely understudied and not understood well enough. And the indoor environment is where we spend 90% of our time at the end of the day. So it's very important to focus on that as well as outdoors. Thank you.
Thank you, Nina. So all of these chemicals that are released indoors, they don't stay indoors. They are mixed from buildings to the atmosphere, and we have good evidence to say that that in the atmosphere, these chemicals coming from buildings are an increasingly large source of organic pollutants. Now, of course, when people think about pollution, people think about cars and trucks in cities. And historically, those were very large sources. But the Clean Air Act has been very, very successful. And motor vehicles have become much cleaner as a result. And their emissions are now so small that other sources have become relatively more important and even dominant in some cases. So those sources include the gases released from cooking, like my colleague just talked about, but also all of the chemical products that we use in our lives, both consumers, but also businesses. And so think about all of the bottles that you have in your bathroom, your kitchen, your garages. Now, in the atmosphere, the main pollutants that we care about are ozone at the surface and fine particles. So both of these are harmful to us if they're present in the air that we breathe. And both ozone and most fine particles are not directly emitted to the atmosphere. They're formed from chemical reactions in the atmosphere. And that makes it hard to control them, because now you need to control the precursors, and that's just harder. So the reactions that form these species involve nitrogen oxides, they involve organic compounds, and they involve sunlight. And we believe that it's the organic gases that are now increasingly coming from our homes and our buildings rather than from cars and trucks. So what are we doing about this? I think the first thing to realize is that buildings are really becoming an integral part of the atmosphere. And so in addition to the stratosphere, where the ozone layer sits, and the troposphere, where we have weather, maybe we should talk about an esosphere, and where the word eso comes from the Greek translation of inside or inner. We need to start collaborating more with my colleagues to the left and right of me who understand emissions inside buildings. And also, we need to collaborate more with building engineers to better understand how gases that are released indoors make it to the atmosphere. So in my talk, I'll present some results that show you what determines if a molecule released indoor makes it to the atmosphere. Some do it very easily, some don't. And an example of a molecule that doesn't is lactic acid. It's a very common molecule in your sweat, in your breath, and it doesn't make it to the atmosphere very readily. And the flip side of that is that it stays indoors and it gets deposited on walls, and that includes these walls too, by the way. And finally, as atmospheric scientists, we really have our work cut out to study what happens to all of these gases released from buildings in the atmosphere. A lot of these are poorly measured by our instruments, which have been, for historic reasons, very focused on the hydrocarbons from motor vehicles. So there's a lot to be done. Now finally, some of you will ask, is it time to do anything about this? It's important to realize that our scientific understanding of all of this is still very limited, and a lot of research needs to be done. One choice that people can make if they're interested is to use less, use fewer chemical products. If you don't need them, don't use them. But obviously, a lot of chemical products serve important purposes. And we have to make sure that alternatives are indeed better for people and also for the environment. So that's it, and I'll hand it over to to Heather.
Thank you. Thank you, and good morning, everybody. So I'm going to be talking about things that are just a slightly bit different. As many of you are aware, construction of new homes that occurred 150 years ago was very different than construction of new homes today. Historically, we used more natural materials like wood, metals, copper, stone to build our homes. And today we use a lot of synthetic materials or materials that are derived from polymers, for example, particularly in insulation and our flooring, wirings and cables, the furniture we bring into our home. And many of these products have chemical treatments to them, treatments that will infer properties such as flame resistance, stain repellency, to make them a certain color, to make them shinier, to make plastics more flexible. And unfortunately, these treatments lead to higher exposure to the general population today than 150 years ago. And this is particularly true for children that have higher contact with indoor dust in particular, because unfortunately dust is a sink for many of these chemicals. When they slowly off-gas or escape from these products over time, they can accumulate in the indoor environment, in indoor air and indoor dust, and lead to exposure. But our understanding of the major sources of these chemicals is still relatively limited. Some of these chemicals are still considered confidential business information. Products aren't labeled with what the chemical treatments are. So it can make it very difficult for consumers to understand where the chemicals are and how they can avoid exposure. So a goal of my research is really to understand how we're exposed to these chemicals and what the main sources are in the home environment. So I'm particularly interested in seeing if we can identify specific products in the home and how they relate to what ends up in our bodies. And today I'm going to be talking about a study we have in North Carolina. We fondly refer to it as the TESSE study, which is the toddler's exposure to semi-volatile organic chemicals in the indoor environment. So SVOCs, semi-volatile organic compounds, are chemicals that are on these types of products that can stay in the condensed phase but also can move into the air. And so we're going to specifically talking about chemical flame retardants that are used in furniture. If we can identify what flame retardants are in these products, how does that relate to our actual exposure and what other variables influence our exposure? And what about the type of flooring in our home? How does that relate to exposure in children? Many of these chemicals have been implicated in adverse health outcomes in children, things like ADHD, autism, neurodevelopmental deficits, and even cancer. And so it's important that we understand the primary sources of these chemicals in the home environment if we're going to actually make more informed decisions and evaluate the risks from these chemicals. So that's what I'm going to be trying to talk about today or this afternoon. Thank you.
So we can start with questions now. If you have a question, please raise your hand. We'll bring a mic to you and kindly state your name and affiliation before your question. Maybe while we're waiting for the first question, Heather, it would be interesting to hear a little bit more about how are you looking at the exposure to these chemicals in the toddlers? What does that study look like?
Sure. So we actually have a team of investigators, and we actually, if families are willing to participate in our study, we actually visit their home, spend about an hour in their home, speaking to the families, trying to understand the behaviors and the products in their home. We've set up air samplers, we collect dust samples, We ask the parents if they're willing for their child to provide a urine and blood sample to understand what's actually in their bodies. And actually, sometimes we take little biopsies of products in the home. So we actually will physically take out a piece of cushion from the furniture, for example, to analyze it in the laboratory and understand what the chemical treatments are. Certainly always with the owner's permission. We don't want to destroy any furniture or any products in their home, but this is unfortunately the only way to understand what chemicals are in products in the home. So it is very intensive, but we collect a wide swath of chemical or samples in the home and try to understand links between these different types of samples and how that relates to exposure.
Okay. We have a question here, and then one in the front.
Hi, Maria Temmings, Science News. I was wondering if Heather could talk a little bit more about how it is that we think these chemicals get inside the body, whether it's through inhalation or skin contact or something else.
Sure. It actually varies quite a bit depending on the type of chemical. For some chemicals, inhalation is a more important exposure route. But for others, we actually believe it's a combination of dermal absorption and hand-to-mouth contact, particularly for things like flame retardants. And certainly more growing awareness of the importance of dermal exposure that Glenn can actually speak to as well, which seems to be quite evident for a certain range of chemicals with certain physical chemical properties. And this is something we really need more research on, because it's not just flame retardants and phthalates and perfluorinated chemicals. You know, our research suggests that there's thousands of chemicals we're exposed to on a daily basis in the indoor environment. And we really need more information and understanding of what the potential health effects are from the combinations or these co-exposures that occur in the home and how they vary from one home to the other based on construction materials used, size of the home, even maybe types of air filtration used in the home.
Question here. Yeah.
I have questions for a couple of the speakers. May I? Okay. Heather, I wanted to ask you, you talked about flooring, and I'm also wondering about flooring, that old flooring that's wood that has been recovered or maybe ground, sanded down, and then with a treatment on it. I want you to speak to that. And Marina and Just, I wonder if you could talk a little bit about some of the, I don't know how to say this delicately, some of the bathroom items, keep the smells down. And sometimes I even go into the public restrooms and they're really heavily scented. And I don't know if you could talk a little bit about that. Thanks.
Well, I guess I'll start to address your first question about the treatments to the flooring. I think certainly that's a very important question. There's certain lacquers and varnishes that are used on top of these floorings that can include a number of different materials, and certainly right after application, those chemicals have a tendency to off-gas. People can actually smell them, right? That means they're in the air and that you're being exposed to them. But the types of chemicals will vary quite a bit depending on what's in there. So in my talk this afternoon, I'm not going to be addressing those types of chemicals, but more specifically focusing on different types of phthalates that are present in vinyl flooring in particular, and how that varies according to how the vinyl is used and installed in different types of homes.
Yeah, so bathroom items. What we call fragrances, what's called fragrances in the industry, reflects a whole bunch of different compounds that in atmospheric science we would refer to as terpenes. The same compounds are released from trees. They smell good. We associate them with natural things, and so the chemical industry puts those same chemicals into chemical products. They're very reactive, so they are actually something we care about a lot. Heather talked about the limited information about the composition of products. That's true for fragrances as well. And because in air, one fragrance doesn't react like the other fragrance, so we'd like to know better what they are. But it's not always the things that you smell that are that have large emissions. If I had to guess what the most dominant organic molecule in this room right now would be, it would be a silicon-containing compound, siloxane, that is present in deodorants, shampoos, creams, many other products. And if this room is anything like a classroom in Berkeley, where my colleagues made some measurements, about half of the molecules in this room, organic molecules in this room, would be siloxanes.
Question here.
Hello, this is Purti, and I'm a science reporter from Research Matters in India. And while we cover most of the research in India, and one of the budding topics there is about how household air pollution is going to be increased because of like activities like cleaning, when there is ambient air pollution already. Adding to that would be when you clean your house with, and then you have a lot of particulate matter in the air, and then also cooking with fuels that are not very friendly for your lungs. So I'm just wondering, in your study, what are there like any particular activities that you can call out to say that is the most harming in terms of air pollution inside the house, and how do you compare it with other activities, and what would be the contribution of things like fur and pollens that are already in the air?
Yeah, I'll take that one. Interesting question. So when we're talking about air pollution, outdoors or indoors, it's very important to discern what category of pollutant we're talking about. So if I were to categorize the experiments we did at HOMEChem, we had 3 main categories of experiments that we believe represent activities we all perform, are very prevalent in homes, and those are cooking, cleaning, and human occupancy, which includes the use of personal care products. When it comes to cleaning and cooking, those activities are likely to lead to 2 different categories of air pollutants. If I were to simplify it greatly, I think cooking would be a major source of particulate matter, while cleaning could be a major source of volatile organic compounds, VOCs. There's a slew of many other types of air pollutants, of course. I'm oversimplifying the answer. When it comes to cooking, of course, the fuel that is used, the heat source, is a major driver of particulate matter formation. So in many countries where solid fuels are prevalent, such as India, that is by far the major source of particulate matter in the indoor environment. What's interesting and new is that as we start using cleaner burning fuels, like in the United States, it's mostly natural gas. At HOMEChem, we had a propane-based gas stove. It's still a source of particulate matter. Those are very, very small particles, on the other hand. And this ties back to what Joost has been saying. As vehicular pollution has been going down, other sources become important, right? As we're cleaning up the fuels that we use for cooking, well, other sources start becoming important. So even though using natural gas might be a cleaner burning fuel, might be better than using solid fuels, well, the next step would be switching that for an electric stove, for example, to further reduce that source of particulate matter. And then at that stage, now we're considering the food as a main source of particulate matter. You're still going to be emitting particulate matter no matter what, because it's a heat-driven process. We're putting things in the air. The key take-home message here is, of course, ventilation is a key parameter in indoor environments. So how the exhaust hood operates, if you use your exhaust hood, the quality of that appliance becomes very, very important, as well as the air exchange rate. Do people open windows? As buildings become more and more energy efficient, they become tighter and tighter, and you might be concentrating those episodic events of air pollution, such as cooking. When it comes to cleaning, we did a variety of experiments during HOMEChem using a variety of products. There was a pine or terpene-based cleaner, so something that smells like a pine scent. We also used a bleach-based cleaner. We used a product that advertises itself to be all natural, and we used a more, even more natural approach, perhaps, depending on your opinion, like vinegar and things like that. Those results are currently being analyzed by colleagues that focus on volatile organic compound chemistry, and these are going to be coming out over the next few months. So I can't comment on them directly right now.
Question here in this third row.
So, following up on when you talked about there's this hierarchy of dirty indoor, burning wood fuel, which they do in some other countries. Here it's mostly a lot of natural gas or electricity. And then when Joost talked about that being a source of some outdoor pollutants, is there a sense of trade-offs and which is ultimately better or worse for you? Like if, like where I live, half of the electricity is still coming from coal. Obviously if it's coming from renewable that's not putting out emissions, that's better. But is there a sense of the trade-offs that may be getting involved here when you're looking at something like particulates or things like that?
Can I start real quick and then you take over? There's always a trade-off. As I just mentioned, even inside the building itself, it's very important for us to think about energy consumption versus keeping a clean air inside your home, right? The simplistic solution from an air quality standpoint would be let's ventilate. Let's bring outdoor air with a very high quality filter all day long. Let's exhaust that air pollution and keep a tight home that has very well treated air. But then your electricity consumption goes up. So from a sustainability standpoint, we do have to consider the feedbacks, the balance between those two things, even just inside the home. And then when it comes to considering broadly our energy sources, and considering indoor pollution versus outdoor pollution, I think the question gets even more complicated. Perhaps you can add some to that.
Yeah, I was going to add that there's always trade-offs. That's totally true. I think the important thing to realize is that with this area of research that we're talking about, it's very early days, and so what we're trying to do is get the facts on all the processes that play a role, so you can start talking about these trade-offs. But we're not there yet.
Agreed.
As you continue to study these chemical reactions, I think you mentioned, some of them are understudied or maybe surprising. Have there been any, the mix of this terpene and that other, in the last decade that have been particularly surprising in the way that they might affect health?
Yes. So I told about the reactions that it takes to form ozone and fine particles from organics, including terpenes. And that chemistry also involves nitrogen oxides. So nitrogen oxides are combustion byproducts from cars, trucks, industries. And they've been steadily going down as well. And as we're now entering a time where those are much lower, the chemistry is starting to change. And that chemistry is now being studied much more as a result. And there was a paper from colleagues some years ago about auto-oxidation reactions. And I'll show some results today where we see one of those reactions actually indoors as well. And as a result of the low NOx conditions in buildings. So it's a very active area of research.
And apart from, maybe using the smallest amount of chemical possible when we're cleaning and cooking, are there other changes that you have made that you'd be willing to divulge, when you're using these chemicals in your own homes?
Well, I think I already covered mine through my recommendations. Since the HOMEChem study, I have a gas stove in my house. Since the HOMEChem study, I use my exhaust hood. Every single time there's an open flame, I use it. And before, I used to only use the exhaust hood whenever I was cooking something that had, smells and I thought would affect my, my perception in the home. But now every single time I turn on my stove, I use the exhaust hood, and I have had it measured to make sure that it's a high quality hood, that it's actually exhausting to the outside. That's been my major. Bought an electric kettle for my tea, so I don't have to use the stove for that either. That's been my biggest change.
Yeah, so I have the fortune to have a mass spectrometer in my lab, so I'm always analyzing things I bring into my home to kind of make decisions on what to buy and what not to buy. But I can say that I think there's some evidence to suggest even simple things like washing your hands before you eat can help reduce some of the exposure to some of these chemicals. A lot of these chemicals stick to our skin, so even showering more often and things like that can reduce SVOCs, at least, that might adhere to your skin. And certainly there's data to suggest that hard surfaces, solid surfaces in the home accumulate less dust than carpets. So I know in my home we made the decision to actually install hardwood floors instead of carpets because we thought that would be better for reducing our exposure. I think having better filters in the home for air filtration. And I always recommend just opening the home. It's, I know we love our air conditioning, but, open the doors, get outside, open the windows. It's good for many benefits for your health and for reducing your exposure to a lot of these different chemicals. But given the proprietary nature of a lot of these chemical applications, it's always really challenging. And that to me is one of the biggest obstacles. So I always encourage people that if you're buying something new for your house, ask what's in it. See if you can get more information on it. Really, it's pressure from the public that helps, I think, bring more awareness to some of the manufacturers and can raise more interest in understanding what we're using and what the potential risks are.
Question here?
Joan Willets, freelance. A lot of us have plants in the kitchen, in the home. Do plants contribute negatively or positively to pollution?
Well, I haven't done any research myself on plants. There are some studies showing, the uptake of air pollutants by plants is very minimal, and their emissions are varied, but probably very minimal as well. Joost, do you agree? Do you have something to add?
I agree with that. There are some people that look at it, but it doesn't seem to be a huge driver.
You have to have a jungle.
Yeah.
Will architects be informed by what you're learning, and will they change the shapes of our houses and our roofs and our alcoves and things like that after they see more definitive results from your groups?
I sure hope so. This definitely highlights the need for interdisciplinary research. The whole reason we proposed HOMEChem was to be a large collaborative study because our secondary goal was to be a community building driver. So we were bringing people from building science, environmental engineering, and chemistry together to try to look at this problem from their different viewpoints and using completely different type of instrumentations and techniques. Hopefully, and we had folks from civil and architectural engineering as well. So ideally, this can serve as a case study for the need for further interdisciplinary research.
Yeah, I just wanted to comment on that. So I have a colleague at Harvard School of Public Health, Dr. Joe Allen, who runs a Healthy Buildings program. And we collaborate a lot on this topic, and so he actually directly advises a number of architectural firms that are really interested in kind of green building technologies, and so they have a really great website too if people are interested. I think they call it the Healthy Buildings Program. It'd be really interesting to check out.
If there aren't any other questions, thank you so much to our speakers. That was very interesting. We really appreciate your time. Thank you.